My name is Vadim. I'm team lead of Deep Agent service in Yandex, and today I will speak about our DeepResearch service on internal data. Quick intro. I work for Yandex for 14 years. I work on Yandex Mail and Yandex D services. Also, I work with road optimization service here in Armenia. Outside Yandex, I worked on some interesting projects like autonomous cars racing and automated blood tests. My hobby is robotics, and right now I'm working on some agents who help my colleagues with some complex tasks on everyday work. Today agenda following 5 parts. First part about why we built our own DeepResearch solution. Second part, it's about how we build it. Spoiler, it's simpler than you think. Next one, how we validate and working on quality or solution. Spoiler, it's harder than you think. Some words about how we work with our code base and what results and takeaways you can take and use in your own company or solution. So why DeepResearch? Every company has some sources of information, some wikis, some discussion in messengers or tracking in tickets on tracking system or something brought down in the code base. And every company has a person who knows everything, walking encyclopedia, and often that kind of person sets status like "do not disturb," and everyone wants to ping him or he or she and ask something about internal context and so on. And every company wants to something resolve this issue, wants something assistant or something which can resolve and help such people. Meanwhile, every employee or engineer spends 10 or 20 minutes to search some information, to grab some coding, to ping the person, and somehow gather some context for everyday tasks. And our service, it's about the instrument, the automation of this person who can answer every time, who can available, and who can give complex answer less than 1 minute. How we get there? What solution do we have in industry right now? The simple one, it's some AI assistant, external assistant, with some common knowledge and without access to internal data. You can ask him some common questions, and but if you have a complex task, it's useless because there is no context in such kind of solution. The next one, we add some ability to search our internal data. We use REC, and it's some kind of one-shot. If we do not have answer in our search result, we are stuck. The next stage, okay, we can add some multi-step solution, some AI workflow, hard-code some business logic about how we work with our data sources, or how we can analyze and summarize results, multi-steps, and so on. But in that kind of solution, like N8N, we have to hard-code every business logic that we have, and it is expensive to support. And if you have some new use cases or some new sources, we have to upgrade our workflow and support the new sources. And the next stage, okay, we want to have some model who can make some decision by itself, like multi-step solution with access with internal data, and which can be flexible and which can do some research, make some search, analyze the results, make some decisions enough. It is in for final answer or it should continue. And this is called AI agent, and we choose that kind of solution for our internal service. Important distinction. People often confuse two these things, DeepResearch and REC. REC, it's about search. We have query, we have top K results, we have some LLM who summarize and analyze results and give the final result. DeepResearch is more complex process when we have searchability, reading ability, some logic about how to interpret results and make trajectory with 5, 10, or even 15 steps to make some deep research through the data, through some logic, and the system decides where it is enough for the final answer. So why you want to build your own deep research in your company? When you speak with your AI assistant and ask it about how can I do that or this, and often you have answer like, I don't understand what you're talking about. In my case, it's what does nirvana mean? Nirvana, it's our internal automation framework, or how our Yandex cloud deploy solution works. And if you have such answers from your assistant, maybe you need some internal deep research solution for your company. So how we actually build our own? Simple diagram. It's intentionally as simple as possible. One backend agent, some Python, some model, LLM model, some tools, research and read. Part about evaluation and data sets, I will speak about it later. Logs, and that's it. Prompt, tools, one engine. AI agent is a very hot topic right now in the community, and in every blog post you can see something like you need the army of the agents, like agent director, agent analyst, agent developer, agent DevOps, and so on. And you have to orchestrate them all, making some communication between them, handoff of context, and so on. It looks like microservice architecture for me. Please raise hands who using microservice architecture on backend in your company. Okay, guys, I think you know the pain. And I prefer avoid this pain until it's necessary. And our decision was to make one agent, no complex orchestration, no deck, no workflows, one agent and tools on the Python. The second important technical decision that we don't want to provide any business logic to our model, how to use tools and how to handle the results. It is example how it logic could look like, and we don't want to do that because it is very expensive to support, and every new use case produce new update of our logic. So we provide our model only prompts like basic one, role, about a list of the tools that it has, and some instructions about final answer or something which important for us. About tool calling, there are two approaches for working with tools and agents. First of all, the classical one, tool calling. We ask our model of the next step. It sends us some declarative structure in JSON or XML, which tools do it need. We parse it, we call the tools in our Python and provide results to the model. Another approach is called CodeAct. It's from researcher world, and it works differently. We provide our model ability to write Python code, blocks of Python code, and ask it every step, please provide us some thought about what the next step is and the block of the Python code. We resolve it, we execute it on our sandbox and send result to the model. This is example of such Python code, and as you can see, model can call multiply tools in one Python code. In this example, we have 4 tool calling and some logic about how to work with the results. And this code provides by the model, not by the developer. And it is more efficient in terms of LLMs calling, because you do not have to call LLMs on all tool calling, and model can combine some approach in the Python and provide us code blocks. But its approach have their own flaws, and the model produce produce some not executable Python code, and we need some effort to help model to work with it, provide some feedback that this Python is not executable and you need to fix this, or some logic and heuristic to try to fix it up by ourselves. Another problem is final answer, because it's also a tool in the Python code, a tool with one parameter, it's big string of the final answer. And validation of this string, it's also challenging, and because we have a different kind of information in our data source, like Markdown, XML, JSON, and so on. Final answer string could be challenging, and we end up with lightweight LM model, which has one task to fix up our final answer string. So another problem with the AI agents with multi-step trajectories, it's context window. Because if we have 15 steps with a big amount of results in each step, you hit the limit and everything goes wrong, and you need to somehow deal with it. So our approach, summarization, classical one. We take steps before we hit limits. We make one message with summarization, replace history with one message, and goes to the next step. But there is problem with summarization, because the first thing, it is important to not forget about what initial task was, because in long trajectory you have a few steps of summarization, and the agent can forget what it's all about. The next one, you have to store all your steps in your trajectory before summarization in some database or logs, because it is impossible to understand what's going on and debug your trajectory with summarization. And last one, summarization, it's very important in terms of quality of the final answer, and if your quality of summarization is not good, the whole trajectory will be not efficient, and final answer will be not so good. So how we actually work with quality and evaluation of our agent? Case from my team and my project, we worked on some prompting and some tooling. Ship it to pre-stable, check some simple questions fast enough, and it feels better. And our changes was connected with the model, and we ship it to production that it feels better. But a week later, we work on our model, and we run all evaluation on the model, and we find out that we drop our overall quality by 20%, and no messages in the support, no feedback from the users that our agent were dumber, because you cannot understand when your agent work quality dropped, because it's some kind of feeling, and you need some instruments to understand what's going on with your quality. So how we work with our agent. Classical approach, if you work with LLMs, you know what bench or basket is. It's some data sets with question and reference answer. We have two types of it in our project. Simple one. It's simple questions that need one or two sources of information. And the purpose of this type of basket to quick check regression and be sure that everything works fine, like model know the tooling, tool works, and so on. The second type of basket, it's more complex one. It's questions and answers that takes up to 1 hour from engineer without context. And it is expensive one because you cannot make it synthetic or acquire this data somehow, not manually. Expensive kind of data set, but you have to have something like this. And the main purpose is to measure the real progress or the real quality of your solution. What kind of question do we have in our hard basket? First of all, it's support questions, and questions from our engineers to our support channels in our internal services or something internal. And people ask real people about the problem or something. Real engineers provide some reference answer. And it's a very important source of data set for us. The next one is code questions. It's questions connected with new employees, new engineers who dive in new project, and they ask some question about how we implement that in that project and how we use that library, and give me example or something about this algorithm in the service. And we can find the reference answer in our code base, or in Stack Overflow like service, internal service. The next one, most frustrating one, it's process questions. It's questions from engineering employee new employee who wants to know how things works in the Yandex. And the answer for this question scattered in number of data sources like outdated wiki pages, some discussions in chats, or someone wrote something in a code base, and so on. Very frustrating one, and very important for new employees to help them to dive into our process quickly. And last one, my favorite one, it's meta questions about deep agent. We have a special effort to teach our model to communicate about itself. And it works like a magic when someone asks our agent, like, what can you do? Or what tools do you have? Or access to what data sources do you have? Or even how you can help me in my use case. And we teach our model how to communicate with our own users. So how we work with our baskets, also a very common approach. It's called LLM as a judge. It's automatic instrument to evaluate something on a basket. How it works? Okay, we have an agent answer. We have some reference answer from the dataset. We have some judge LLM, stronger or bigger one. That scores our answer by correctness, completeness, and relevance. And this point of some recursion, because you have to judge your judge, and it is a tricky process, because if you do not trust your judge, you cannot trust the overall evaluation of the system. And you have to do it by yourself, review by humans, and provide some additional prompting and examples how to judge properly. Another interesting things in what we log in, we log almost everything. For example, we log every question in the production, log every broken tools or tool calling in our code. What type of information our users wants and so on, and do we have access to them, and some problems with code, because it is important because of code act nature of our agent. It is interesting that that kind of sources can be used for self-improving for an agent, because we can ask our agent to monitor that kind of data and understand what new use cases do we have, or what tools do we need, or what access do we need next to be more effective and to do more things for our users. But tools and prompting not enough for models, and we have some restrictions about the proprietary external LLMs, and we need to work our own models because of security and restrictions, and we have to fine-tune some models with our scenarios. So we using fine-tuning on trajectories. How it works? So we have a question in our data sets. Our AI agent model agnostic. We can switch models in our agent very easily. So we prepare some agent with different models and run baskets on them. We acquire some trajectories from different agent. We have a judge who can filter out trajectories with wrong answer or some not efficient one. We make data sets from trajectories, fine-tuning with LoRa, QLoRa, SFT, or DPO. Make new fine-tuned model, eval this model on our basket, and go to production if it has more quality. So it is important to understand that we do not fine-tune our models on the pairs of question and answer. We don't teach our model how to write answer, but we teach our model how to make trajectory, make two steps, make some decisions or some tool calling for get the right answer. And some interesting about that multiple LLMs produce very diverse trajectories, and it's very useful for training, because every model has own threats and resolve and working with the task in a different way, very creative one. And it is useful to show your model how things can be done. Another thing that judge filter out some trajectories with wrong answer, but not all of them. It is useful to show model how things can go wrong and what you can do about it in your trajectory. The next one, important insight for us, that fine-tuned model can outperform the bigger and smarter model. So we can use more cheaper inference model, fine-tune it, and the quality of the solution will be comparable with a bigger and smarter model. And this kind of pipeline or workflow, when you work with your data set, fine-tune on trajectories and evaluation, can be automated, and it somehow may be a self-improving process for your agent. So a few words about how we work with code. We have a huge monorepo in Yandex, 28 years of code. And there are two constraints about it. First of all, it's huge, and we cannot provide all our code base to model even with 1 million, 1 million context window. And we somehow need to provide something else. The next one, it's security. We cannot provide the external model, our internal code base, or even for internal models, we cannot provide some essential part of our code base. So we provide agents some tooling, and it can work with our code base. To approach. First, it is semantic search. It's reg-based. When model do not know which data, which code do it need, it use some semantic search. And after that, if it knows like something, like name of the function, name of the method, or something, it use regex search. So what the result of our solution after 6 months of the production? First of all, we provide some instrument that reduce searching time from 10-20 minutes to less than 1 minute with comparable quality. We have 1,000 questions every day. And it's 40 hours of searching that you can avoid. And it's 30 FTE, which can be redirected to real engineering. Not a bad result for a team with 5 people. Okay, what takeaways do we have? So first of all, start with prototype. Our first prototype was built in 2 days. Some script, some simple search, reg-based, and LM for summarization. Quality was terrible, but 1 of the 10 answers was shockingly good, and it is enough for proof of concept to show your colleagues that that thing can work. The next one, avoid over-engineering such system from the day one. You do not need complex solution for something like that. You can take a solution as simple as possible, and in our experience, it can work. From engineering part, if you work with AI agent, you need some eval-driving development. You need some basket, you need some instruments for evaluation. It is a crucial part of working with your quality. From engineering part of agent, code execution works better than tool calling, and give your model some freedom to write Python code, and it can do that. And fine-tuning on trajectories are working. You can use some not big or smart models and fine-tune it for your scenarios and make a good result. So that's it. Thank you everyone.